talk about Hertz, Heinrich Rudolf Hertz. Now, he was one of the first ones to come up with a practical radio transmitter. And he is, like if we say kilohertz, megahertz, the name for the cycles per second or frequency of a radio frequency is named after him. Now, he was an interesting person. You know, he only lived to be about 39 years old and had a pretty successful life up until then, but he died of an incurable disease and didn't get to do all he wanted to do with his life. And he only lived to 36. He was born in 1857 and lived to 36. What he did was he made this first primitive transmitter. It has DC that is supplying a feed to this key right here, like a key for a telegraph. And when that keys this coil, it's making an induced current, which is then transferred. This is a transformer, primary, secondary. This increases the voltage. This is a step-up transformer. And that's making a higher voltage over here. And when that voltage, it comes across this spark gap here, and it goes to these two antennae. It's not going to the ground, it's going to two antennae. But what he found was if you take this ring of wire or metal, that when you were keying over here, you could hold this ring over here and sparks would jump between that point. And so he demonstrated early radio transmission by this method. This would spark over here, and then he'd hold this ring in space, and it would spark. And that was a very interesting way. But that was the first demonstration of practical power transmission or radio transmission, and that was done back in the 1890s by Hertz. Nikola Tesla. Nikola Tesla is someone everyone talks about a lot. He invented so much, and we owe so much to him for our modern technological world. This was his version of a spark gap transmitter. It's very similar, but what would happen is you'd induce a current, a DC current into this coil. It would cause a spark here. It would feed through two capacitors here, and then through two more coils, making a spark there, and then this would go to ground, and that would go to an antenna. But that was his version. So they all had their own individual version of spark gap transmitters. He was involved in the war of the currents. He was in a big war with Edison over the difference between AC and DC. Edison had a lot more power than he did, but Tesla's better designs won out in the end over all of that. I want to talk about the Wardenclyffe Tower. Now, this was known as the Tesla Tower. It was an early wireless telecommunications tower designed by Nikola Tesla, and it was intended for power transmission. Now, this is a very interesting thing. You know that when Tesla first came out, he wanted to be able to take and send electric power directly to the receiver. Like if you're on land and you want to run a ship at sea, you can transmit that electrical power to the ship and then run its motors and so forth. This was the first experiment with that, and he could have done it, but the problem was it was funded by John Jacob Astor, and Astor was wanting to know, if we transmit power out into the world for everyone to use, how are you going to put a meter on it? And so when they figured out that Tesla's design was going to allow people to get electrical power without being charged for it, they pulled the plug on that. But this is how far it got. They actually built the building, and they had this big tower here, and they were going to put a big dome up here, and they was going to send radio signals to Europe or anywhere in the world, and they were going to be able to power ships and anybody that had the receiver where they could actually draw from the power and use it to run circuitry, motors, or whatever. But when they found out that, you know, people could just hijack the power and not pay for it, they ended his funding, which upset Tesla terribly. But he didn't have much choice in that. Let's take a look at how that would work. Here's a section of the surface of the Earth. And let's say that we put our little transmitting tower here, and then he would send out a very low frequency signal. And it would also be tied into the ground. And so that would induce a sine wave charge. And it depends on the Earth being able to have a charged ionosphere or being a charged particle in space or body in space. And so here's this signal, a low frequency signal running through the atmosphere. At the same time, an inverse signal is induced below. And let's say I put a ship here. And this ship has a receiver, and then it's tied to the ground. That would induce a voltage between here and here that could be drawn on to do work. Now that was an amazing thing. I mean, you can still transmit power. He demonstrated you could transmit power. But I don't really know how that would have affected the ionosphere or the atmosphere or other things other than this receiver if that was working. I could see damage to the ionosphere, and that would have consequences like we're having today with the depletion of the ionosphere through other things being put in the atmosphere. So that might have saved a lot of trouble, but it's an interesting thought nonetheless. This was also a radio transmitting tower. He was planning on building an equivalent one in Scotland that would send signals between the United States and Scotland. But he sort of lost favor when he couldn't demonstrate a monetary way of making money from this system. Okay? Here's another picture of Tesla, and what he is demonstrating here is wireless power transfer. He's holding two fluorescent tubes, and he has wires up here containing a high voltage, and he would hold those tubes in space and illuminate them. And that would show that you could actually, he's standing right here and he's holding these, and you can actually see them lighting up, or that's what they were doing. And people could see the demonstration of how this power between these two plates would illuminate those bulbs.